Hello and welcome to this second film about covalently bonded substances and their electron dot diagrams. Hopefully you've watched the first one and you remember the rules that we used there. This film should hopefully be quite a lot shorter than that first one, which went on for a long time. This one deals with some of the more complicated types of electron dot diagrams that you might see in year 11 and 12. And hopefully by the end of the film you'll be able to draw electron dot diagrams for compounds that are made up of compound ions. So not only is the compound made up of different atoms, but the ions that make up the compound are themselves made of different atoms. Okay, so here we go. Here's the first one, and it's magnesium carbonate. Now, magnesium carbonate, how do you know, first of all, that it's ionic if you're faced with it in a test? Well, it's a metal combined with non-metals, so it's going to be ionic. Spotting the ions is a little bit harder. You need to remember something about the carbonate ion, and that is its formula. Okay, so we've got two ions here. We've got the magnesium 2+ ion, and we've got the CO3 2- or carbonate ion, and we're going to have to draw electron dot diagrams for both of those. Now, the metal ion should be very straightforward, really. As we saw earlier when we were doing electron dot diagrams for ionic compounds, a metal atom is always going to want to lose its electrons, and magnesium's in group 2, so it's lost 2. It's left with a 2+ charge, but no outer shell electrons. And so any time, remember, that you draw a metal ion electron dot diagram, it's going to look like that, except the name of the metal, or the symbol for the metal, is going to vary, and so is the charge on it. But there's never going to be any electrons shown, because metals lose their electrons when they react. Now here we've got two non-metals combined, so we're going to draw an electron dot diagram for this. Carbon is in group 4, oxygen is in group 6, but there's 3 oxygens. There's also a 2- charge, so we're going to add 2 electrons, and that gives us a total of 24 electrons, or 12 pairs. Okay, so here we go with our electron dot diagram. I'm going to go through this a little bit quicker than before, because you can always go back and see the rules again if you've forgotten them. But first thing to do is to join all the atoms to the central atom using single bonds. I've got 12 pairs, so anyway, next step is to fill the outer shells of all the atoms. I've got those oxygens full now. If I fill that oxygen and that carbon by giving it another pair, I'll have used 13 pairs. So I'm going to give this oxygen 2 and another one by giving a double bond there. Now the carbon's got 4 pairs, that oxygen's got 4 pairs, and so do they. Last thing to do is to put a square bracket around it, because I have to show a charge. Whenever there's a charge, there should be a square bracket. So there we are, that is there, that thing we see here in the green, that is the electron dot diagram for magnesium carbonate. This isn't a compound ion, it's just a single metal ion. This is a compound ion. Okay, the next case we're going to look at is going to involve a negative single ion, and the positive ion is going to be the compound ion. Remember, this ion here is the only non-metal positive ion, so you need to look out for it, because it's the NH4+, or the ammonium ion. So this is ammonium chloride, and we've got a chloride ion with it. So although you can't see a metal here, this is an ionic substance. However, this ion here is made of non-metals combined, so it's going to have covalent bonds in it. Put the working up here. Okay, so nitrogen is in group 5. Hydrogen, that's in group 1. But there's 4 of them here, and there's a +1 charge, so I've got to take 1 electron away, because this has lost electrons. So that gives me 8 electrons, or 4 pairs. Okay, so nitrogen is the central atom because it's first named. All the others join to it with single bonds. We've seen this ion before, hopefully. It's called the ammonium ion, as I mentioned earlier. Hydrogen has only 1 shell, so it can only hold 1 pair of electrons. So these 4 hydrogens have already got full outer shells, and so has the nitrogen with its 4 pairs. I've used 4 pairs altogether, so that means this electron dot diagram is finished. And then the other ion that I have to draw an electron dot diagram for, that's a chloride ion. But remember, chlorine's in group 7, it gains 1 electron to fill its outer shell. So it's just typical non-metal electron dot diagram, that is to say 4 pairs around a single atom. Got to show the charge, minus, and remember, anytime there's a charged ion, it's like saying the same thing twice, but anytime there's a charged particle in an electron dot diagram, make sure you put a square bracket around it. Okay, that just leaves one example for this film, and that is ammonium nitrate. We can go through this a little bit quicker because we've seen the electron dot diagrams for both these ions already in this film. Okay, but we've got NH4 plus and NO3 minus. So very quick working here. 5 for the nitrogens, 1 times 4 for the hydrogens, and a positive charge. That means 8 electrons or 4 pairs. Here we've got a group 5 element and group 6 element, oxygen times 3. We've got a negative charge, so that adds an electron to these guys, so we've got 24 electrons here and 12 pairs. Right, so there's going to be 2 things in square brackets because they're both ions. Right, one of them has a single positive charge, one of them has a single minus charge. And we've got 4 pairs to play with here. Nitrogen is the first named atom, so it's in the center. We join all the other atoms to it with single bonds. All the shells are full here because nitrogen's got 4 pairs and hydrogen's got 1. Remember, it's in the first period, so it can only hold 1 pair of electrons. In this one here, rather like before with the nitrate ion, we're going to do a double bond here and 2 lone pairs, single bonds here and 3 lone pairs on each oxygen, because we've only got 12 pairs to play with. If I'd put a single bond there and another pair of electrons there on the oxygen, I'd have had 13. So I've just skipped a step there, but we've seen how to do this before, hopefully. Okay, so they're the kind of, I suppose, the most complicated electron dot diagrams you're going to see in a Year 11 or 12 test. It's great if you can master them in Year 11, but you need to do them again in Year 12, and if you're good at them by the end of Year 11, then you don't really need to put the work in too much in Year 12, just a little bit of practice. So good luck with them.